All right. Yeah, welcome back to my class. Today we are going to look at bitwise operators. These are the engineers of the realm. They operate at the lowest level, the foundation of data, which is what? 0 and 1. So that is where they operate. So we have uh, bitwise AND, right? Then, which is what? This sign. Then we have bitwise OR, which is just this pipe, just one pipe. The logical AND was two of these for logical OR. Then we have the NOT, the bitwise NOT, which is like this. Then we have bitwise exclusive OR, right, which is this symbol. Then we have the right shift and the left shift. So we have uh, left left shift. This left shift is this, and then we have the right shift, which is this and this. So these are the operators that we have in Bitwise. So the Bitwise operators, these are the engineers that work at the foundation of data. So this is going to work on 0 and 1, 0 and 1. So I'm going to write a very simple program now to explain these 6 operators, right? The AND, the OR, the NOT, the exclusive OR, then left shift and right shift for the bitwise operators. All right. So let's write our program. So we say include, we'll do this, include stdio dot h. Then here I will say int main. We'll write our main function, and then we'll open the curly bracket. Now I'm going to declare 2 variables, and I will assign values to them. So the first one will be int a, and I will assign 60 to it. Then next one will be int b, and I will assign 13 to it. Yes, so randomly I'm just picking these numbers. Now, before we can continue, I want to convert this to binary. I will convert this to binary. So to convert 60 to binary, I'm going to have something like this, right? 2 going to 60, that will be 30. Remainder 1, remainder 0, right? 2 going to this, that will be 15. Remainder 0. 2 going to this, that will be 2 going to 14, 7. Remainder 1. 2 going to this will be 3. Remainder 1. 2 going to 3 will be 1. Remainder 1. 2 going to 1 will be 0. Remainder 1. Now we are having 1, 2, 3, 4, 5, 6. So we are going to add to make it 8-bit. So this, then for 13, we have 13. 2 going to 13, going to 12, 6, remainder 1. 2 going to 6, 3, remainder 0. 2 going to 3, 1, remainder 1. 2 going to 1, 0, remainder 1. So you are counting upward like this. You are counting upward like this. Right? Okay. So now this is what we have for this. We have 1, 1, 1, 1, 0, 0. This one we have 1, 1, 0, 1. Now we want to make it 8 digits. So it will be 1, 1, 1, 1, 0, 0, 0, 0. We add 2 zeros. Then this one will be 1, 1, 0, 1. Then we have 4 zeros. So that is how you get this. Now I'm going to write my program to use the bitwise operators to work on this. So this one will give us this one will give us 1, 1, 1, 1, 0, 0, right? 1, 2, 3, 4, 5, 6. So I will add 1 0 here and another 0 here. Then this one will give us 1 0 1 1. So I'll add 1, 2, 3, 4. So this had these 2 digits. This one is for 60, while this one is for 13. Now I'm going to write my program to now use the operators on each of them, right? That's what I'm going to do now. I'm going to clean this off. Then I will say, in this place, I will now say print F, and I'll bring in the first operator, which is AND. So I will do my quote, and I will say AND. Then I will say A and B, right? Equals to, that is assignment operator. Then I will do percentage D, then this, and I will close, and then I will say A and B. Then I'll say print F. I'll put this quote again. Then I'll say or A or B. Then I'll put my format specifier, and then I'll format specifier D. Then I'll put this, and then I'll say A or B. Then I'll close. Then here I'll say print F. Then not. Then I will do this for A, and then I'll put my format specifier, and then new line. Then I'll say not A, and I'll close this. Then I'll say print F, exclusive or. Then this one will be A or B. Then I'll put my format specifier, new line. I'll close this. Then I'll say A or B, exclusive or B. Then I'll close this. Then print F. I will do for the left, for the left shift, that would be, I'll just do left shift, right? Then I will say A left shift 2. And then I will assign this N, then A left shift 2. I will explain. You will not be able to see further, so I'm just going to end the source code here. Then I'm going to return 0. And then my curly bracket, I'm going to close it, right? So I hope you can still see this part. So I will leave it like this. For the right shifts, I'm going to explain that one later on the board. So let's explain the output of this source code on the screen. Now, A and B, right? Looking at this is our A and this is our B. Now, if I'm going to do this, the AND operator is just like the logical AND, where I told you that it is like a switch. You know, it is like a switch, like this. Now, this and this will have to be on for you to have on as the output, right? So 0, 1 will give you 0, 0, 0 will give you 0, 1, 1 will give you 1, 1, 1 will give you 1, 1, 0 will give you 0, 1, 0 will give you 0, 0, 0 will give you 0, 0, 0 will give you 0. Now, this is what it's going to give you. This is 0, this is 1, then the output will be off. This is 0, this is 0, the output will be off. Then this is 1, this is 1, then the output will be 1. This is 1, this is 1, the output will be 1. Now, in the memory, this doesn't make any sense. The only reason why the CPU will be able to interpret this will be based on the instruction that has been created by the compiler. So, and the compiler will create the instruction based on the data type. So looking at this, we have int A and int B. By default, there are two communities in the realm of integer data type. That is the unsigned and the signed. So when you look at this, and you are not writing signed or unsigned, by default, this is a signed integer. So it means when you enter into the integer realm, you still have to go to the community, which is what? The signed community. That is what this is. If it is unsigned, you will have to indicate it here as unsigned. So unsigned, what I mean by that is, if we are looking at the 32-bit system, that would be 2 raised to power 32. Do you understand? I hope you understand. If I have to write this out, to be very long. So you can use your calculator to do 2 raised to power 32, what it will give you. So for sign, you have the sign, negative sign, and the positive sign. But for unsigned, to be 0 to 4, which is within this range. That is what I'm trying to explain. Now, when you look at this, the CPU, this will not make any sense in the memory. So you can only get the meaning of this binary through the lens of the data type. So in this case now, it is a signed data type. So in interpreting this, we have to now convert this back to decimal. So in converting this back to decimal, I might have to clean some things. We'll do this one will be what? Let's do from here. So 0 times 2 plus 0. So 1, 2, 3, 4 are all 0. So it will give us 0. So I have 1, 2, 3. So I am just going to do 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2. Now, which is 0, 1, 2, 3. If you look at this, this is 0. So even if I continue, this will give us 0. So 2 raised to power 3 is 8. Plus 2 raised to power 2 is 4. 2 raised to power 1 is 2, but multiplied by 0. So this one will still give us 0. So this will give us 12. So this output is 12. Right? This is what this output is doing. If you don't understand what I've just said, you can put that in the comment section. And then I will also reply you in the comment section how I converted this binary back to decimal. How I converted this decimal to binary. And then I'm reversing it. So this one is going to give us 12. Right? So for this and will give us 12. Then or will give us, if we do this now, for the or, let's come back to this place. So 0 and 1 will give us 1. If either of them is 1, then it will give you an output 1. Then 0, 0 will give us 0, right? 1, 1 will give us 1. 1, 1 will give us 1. 1, 0 will give us 1. 1, 0 will give us 1. There is still a truth table. Please, if this is looking confusing to you, you can look at my lecture on logical and logical OR, and then you'll be able to see the truth table. That truth table also applies to this, right? So this is false, this is true, so it will be true. This is false, so this one will be 0. That is for logical and logical OR. But for this is bitwise, so it's at the bit level. Now this is 0, this is 0. If I have to convert this, what will it give me? So following this same pattern, I am having 1 here, So 0, 1, 2, 3, 4, 5. So this will be 2 raised power 5 plus 2 raised to power 4 plus 2 raised power 3 plus 2 raised power uh, 0, 1, 2, 2 raised power 2. So what would this give us? This one will give us 32. This one will give us 16. This will give us 8. And this will give us 4. Right? So this plus this, that is 12. So this is 4, 8 plus 12. There's another 1 here. This is 1. This was give us 2 raised power 0. 2 raised power 0, that is 1. So that is 1. So this one plus 1. So 48 plus 12 plus 1. This is, that will give us 6. So this one will give us 61. So this one will give us 61. Right? So this will give us 61. This will give us 12. This will give us 61. Then we are going to do this knot. Now, with this knot, you will really be able to appreciate what I meant when I said unsigned and sign. This is a signed integer. So we are going to flip. This one is going to invert everything that is A. Now, this is A. This is A. So this not A will now be 1, 1, 0, 0, 0, 0, 1, 1. Which is this? This one. Not A will be this. But how are you going to interpret this? Now, I told you that this has no meaning unless viewed through the lens of the data type. So what is this data type? This is signed integer. So in a signed integer, this digit here determines the sign. If it is 0, that means positive. If it is 1, that means negative. So in interpreting this, we have to use two's complement. Is another concept, two's complement. So what two's complement does is that I'm going to flip this again and then add 1 to it. So when I flip this, it will bring me back to this. Then I will add 1. So that will now be 0, 0, 1, 1, 1, 1, 0, 1. But this sign is for negative. So this one will give me 61. But because of this sign, it will give me minus 61. So this one will give me minus 61. Right? That is what it will give me. I don't want this class to be too long. So this bitwise operator, I'm going to divide it into 2 classes. Right? So at this point, I am going to cut the video here, and then I will bring in the next video in the next class. So till we see in the next class, bye-bye.